Alright, so sorry about that. The previous video cut off, but anyways, let me just pick up where we left off. So we said if we increase the significance level, type 1 error goes up. If you look back at the previous 2 videos ago, you'll see that type 1 error is the same as the significance level. But if type 1 error goes up, type 2 error must go down because you cannot have both errors at the same time. Therefore, right, type 2 error will go down, therefore the power goes up. The downside of this, the downside is what? That the type 1 error goes up. Because we don't want type 1 error to go, we don't want any error to go up. Type 1 error increases. But there's a trade-off here, and this is one of the downsides. Moving on, the previous video already talked about significance level and 1 sample or 2 sample. I want to jump right into right tail and left tail. So 2G is asking if it's right tail or left tail. Remember, 2 is talking about Mike, so I'm on problem 2 right here about Mike. So Mike's free throws equals 0.5. The alternative is the free throws. I've got about 3 minutes left on this video, folks, so just hang in there with me. Mike's free throw percentage is greater than 0.5. Now, if you were thinking about whether it's a right tail or left tail or 2 tails, think about this, folks. If we talked about a little distribution here, called this 0.5, our alternative hypothesis is that Mike is greater than 0.5. Greater than 0.5 is here. Here's greater than 0.5. So what does that mean? That means we are a right tail because the null hypothesis, because the alternative hypothesis is greater, so we're on the right. In comparison, 7G, this is the dog problem on the back. Null hypothesis is that the mean of A equals the mean of B. Alternative hypothesis is that mean of A does not equal the mean of B. So here we go. If we talk about this picture, let's draw a picture here. And down here I've got the mean of A minus the mean of B. So our null hypothesis is that the mean of A equals the mean of B. If that's the case, then this equals this, which means this minus this is 0. Let me say that again. If the null hypothesis is true, then the mean of A equals the mean of B, which means mean of A minus B. And again, why am I doing this? Because it says difference, which is subtraction. Then this must equal 0. The alternative says that this doesn't equal this. So this could be like 20 and this could be 10. If this is 20 and this is 10, then 20 minus 10 is 10. Alternatively, if this is 8 and this is 10, 8 minus 10 is negative 2. So this does not equal could be a left tail or a right tail, so we call it a two-tailed test. We call it a two-tailed test. Why two-tailed? Because we are doing does not equal, so it could be on either side. Remember, two-tailed does not mean the same as two sample. Two sample is, do I take 2 samples? Two-tail is, are we talking about not equal? Because then it could be on either side. And finally, let me finish up here. 7H. Why don't we start with 2H? So back to Mike and the basketball. Critical value. So critical value is used in the t-test. Tomorrow in class we'll talk about how it's used in the t-test. And we need the degrees of freedom and the sample size in order to find this. Degrees of freedom, we don't need degrees of freedom and sample size. We need degrees of freedom and, I cannot believe I did this, significance level. So what are degrees of freedom? Degrees of freedom are n minus 1, and n, of course, is just the sample size. So for Mike's example, it says he took 57 free throws. So 57 minus 1, so 56 is the degrees of freedom. Significance level, or the alpha, 0.05. So let's find critical value. So in order to do this, we need we're going to use the table. So the T star, which is just the critical value, equals what? Well, let's look at our table. Let me get our table out real quick. I hope I have it somewhere here. It's kind of buried. As you all know, I have a lot of paperwork, probably too much. Here we go. So, our degrees of freedom are 56. Degrees of freedom are 56, and significance level is 0.05. So, here are degrees of freedom. This is what I gave you on Monday. 56 isn't here, so I'll go to 60. And alpha is 0.05. Here's 0.05. Come down 60 right here, 1.671. 1.671. So how do we do that again? We said degrees of freedom were 56. 56 is not on here. This is the degrees of freedom side, so I went to 60. Significance level was 0.05. That's where they overlapped, 1.671. Now, let's find the critical value for number 7. So 7H. So, critical value for this one. So, the T star, we need the degrees of freedom, and we need the significance level. Significance level, they don't tell us, so we assume it's 0.05. It says nowhere in here does it say significance. I assume 0.05. Degrees of freedom, I do N1 minus 1. Because this is a two-sample test, I have to find the degrees of freedom for both samples. So for N1, N is 43. 43 minus 1 is 42. For the second sample, N is 41. 41 minus 1 is 40. And then, here's the key, pick the lower one. So the degrees of freedom are 40. We got the degrees of freedom. Everybody's going to want to say the significance is 0.05. And they're right. The significance level is 0.05. But for the critical value, we have to remember something. Because this is a two-tailed test, up, down, this side, we divide the significance by 2, since each side has half. In other words, there's 0.025 here and 0.025 here. Add that up, that's 0.5. So the significance level is 0.05. That's right, 5%. But only 2.5% is here, 2.5% is here. So you have to divide alpha by 2 when there's a two-tailed test. So alpha is really going to be 0.025. So now I'm done here. T star with a degrees of freedom of 40. Remember, we took both and we found the smaller one. 40, comma, 0.025 is equal to what? Well, let's go back to our table. Degrees of freedom are 40. Here's 40 right here. 0.025 coming right down here. 2.021. 2.021. And that's the positive side. You got to get the negative side also. Negative 2.021. So because it's a two-tailed test, we had to split the degrees of the significance level in half. Because it was a two-sample test, we had to do this for the degrees of freedom, check both and pick the lower one. And then, because it was a two-tailed test, we have to have the positive and the negative critical value. Let me stop here. A lot to do, a lot of work. We are making progress together, and tomorrow we'll pick right back up.